Learning objective C is going to have us find the falling or throwing object model. And this is the standard format of it, which you did have back in Algebra 2. But in Algebra 2, here's actually what they gave you, is they had h equals negative 16t squared plus velocity times t plus h sub o. Now, this particular model, being that they've put negative 16 in here, means this is only for planet Earth. This actually has the gravitational force of Earth computed into it. So what we now have is a more advanced model. The velocity times the time and the starting height's the same here, but instead of giving us negative 16, they're going to allow us to use this on any planet. So let me tell you what the variables stand for. So the variables stand for this V sub O is called initial velocity, and that is just speed with direction. So if we're going, 10 feet per second forward, it's plus 10. H sub O is the initial height in feet, so that goes right here. So if we're jumping off a diving board 10 feet from the ground, we'd say 10. The ending height is also in feet, and that's right here. This tends to be the answer we're trying to look for sometimes. The t in the equation, there's two of them, is the time in seconds. And the new component we have is g. It's called acceleration due to gravity, and there's two different units of measure, either in feet per second squared or meters per second squared. The problems will tell you which ones to use. If we're measuring in feet, we have to use 32 for g. If we're measuring in meters, we have to use 9.8 for g. Let me show you how the formula works. Okay, so our scenario is here. A ball is thrown upward from a height of 15 meters with an initial velocity of 20 meters per second. Okay, so we are looking at terms of meters, so that means the g, or the acceleration due to gravity we're going to use, is going to be the 9.8 meters per second squared. Part A wants us to find the relation between height and time after the ball is released. Part A really just wants the equation. So let's write the equation. So we're going to say that h is equal to negative 1/2. The g is going to be 9.8. And we're going to keep t there as squared because we don't know it yet. Here we have the velocity. It's going thrown upward. So the velocity would be 20 as a plus, 20 with the t. The initial height is 15 meters, so that goes right here. Now we should simplify the negative 1/2 and the 9.8, so that means h is going to be equal to negative 4.9 t squared plus 20t plus 5 plus the 15. Now, if we look at part B, they want to know how high the ball is after 3 seconds. So that's just the time question. So for part B, they're saying, hey, if t is 3, what's the answer? So all we have to do is put in the negative 4.9, do 3 squared, plus 20 times the 3, and then plus 15. Be careful when you simplify. Do 3 squared first, then times it by negative 4.9, we'll get negative 44.1, then plus 60, and then plus 15. When you simplify those all together, we're going to get, answer is 30.9, and it's going to be in meters. Now, part C wants to know when the ball will hit the ground. Well, keep in mind this equation right here represents a parabola because it's a t squared or x squared. And the leading coefficient, or the value in front of t squared, is negative. So this parabola is going to face downward like that. Well, they want to know when the ball is going to hit the ground. Well, in this case, our x-axis is the same as t for time. And the y-axis is our height in this case. So when is the ball going to hit the ground means when is the y-axis going to be at 0, or the y value. Well, the y values are going to be at 0 at this x-intercept and that's at this x-intercept. Recall to find the x-intercepts. X-intercepts happen when y is 0. So all you have to do for part C is set y equal to 0, or in this case, h equal to 0. So when we do that, here's what we get. Now, this is a quadratic, and I need to either factor it and find the zeros, or the x-intercepts, or I have to do quadratic formula. Unfortunately, on this one, a quadratic formula is my only option, so let's do it. X equals negative b plus or minus the square root of b squared minus 4 times a, and then times c. That's going to be all over 2a. When we first start our simplification, it's going to be negative 20 plus or minus the square root of 400 plus 294 all over negative 9.8. And that's going to give us a negative 20 plus or minus. I'm going to take the square root of these two combined values. So the square root of 694 actually gives us 26.34. And then we're going to take all of that and divide by negative 9.8. Now let's break it into the two parts. Let's do the plus portion first. So if it was negative 20 plus 26.34 over negative 9.8, what we're going to end up getting then is going to be a negative 0.65. So for time, that actually doesn't make sense. So when we do the other one with subtraction, so let's do the second split on that, it's going to be negative 20 minus the 26.34 over negative 9.8. Combine the top to be negative 46.34, then divide by negative 9.8. And what you're going to get is 4.73 seconds, which is the only viable answer here. The negative time did not make sense. Let's look at another example. It says here a projectile is shot from a tower 10 feet high with an upward velocity of 100 feet per second. So I'm going to sketch that out real quick. Okay, part A wants us to approximate the relationship between the height in feet and the time in seconds. So that's where we're going to keep the h there, the t squared and the t, and we're just going to fill in the missing parts of the g, the v, and the h sub o. We are talking about in feet, so for the g value, we're going to be using the 32 feet per second squared. Okay, so if we fill it in, we don't know h, that's the ending height, but we have 1/2 of 32 t squared. Now the velocity is 100 feet per second, so it's speed, which is 100 feet per second, but with direction. And it's going upwards, so that would be a positive. So plus 100 t and a starting height of 10. And let's simplify that equation. So we have h equals negative 16 t squared plus 100t plus 10. Now part B wants to know how long the projectile will be in the air. So if you imagine that the picture of this parabola was sketched on graph paper, if this is the x, y axis here, they want to know how long it's going to be in the air. So really, the question that they are having is when will it hit the ground? So if this is the ground right here, this is where we want to find the x-intercept or the zero of this function. So again, to find the x-intercept, we set y, or in this case h, equal to 0 and solve. So I'm not sure if this one is factorable, so I'm just going to go right into the quadratic formula and set that up right here. So let's identify a, b, and c first of all. I'm going to write it up here. A is negative 16, b is 100, c is 10. So I'm going to do the x equals negative b plus or minus the square root of b squared minus 4. A is negative 16 and c is 10, all over 2a. And let's simplify. So simplifying, we're going to bring everything under the radical together and get 10,640. If we continue and take the square root of that, we will get negative 100 plus or minus, this becomes 103.15 all over negative 32. Now, if we split this one off into the plus side, if we do negative 100 plus 103.15, it'll be a positive value on the bottom, but then divide by a negative 32, we will get a negative answer. So this one will give us a negative answer, so I'm just going to continue on and actually know that this one will be negative and not continue. So then do the negative side, so negative 100 minus 103.15 divided by negative 32. When you do that, it's going to be negative 203.15 divided by negative 32 will give us the answer of 6.3, and the label for time is in seconds.